wasted and no value. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all the judges of Mardi Science and Technology Exhibition 2021 and all the viewers around the world. My name is Muhammad Anas bin Haji Otaman, and I'm a Senior Research Officer under Young Agripreneur Program in Technology Transfer and Entrepreneur Development Center, Mardi. My background is in food biotechnology, and more specific is in fermentation technology. And today I would like to present my project that entitled Okara yogurt from waste to value added product. And my collaborators in this project are Dr. Azrina Manso and Siti Khadijah Mahadi from Food Science and Technology Research Center, Mardi. Ladies and gentlemen, the substrate that I just showed you just now is called Okara or soybean curd residue. It is a soy byproduct generated during soy milk and soybean curd or tofu production. It consists of insoluble parts of the soybean seeds that remain after the aqueous fraction extraction. Okara is rich in dietary fiber and other nutritive substances such as mineral elements and also phytochemicals like isoflavone, saponin, and also phytosterols. Therefore, it has a great potential as a functional ingredient in human food. However, high in moisture content has made it susceptible to spoilage and difficult to handle. Therefore, it is used as animal feed, biofertilizer, or just being dumped in landfills, which cause environmental and economic problems. Many researchers have shown that Okara is a potential prebiotic substrate that could support the probiotic growth and survive under stimulated gastrointestinal conditions. The dietary fiber from Okara can pass through enzymatic digestion and acts essentially as a substrate to the intestinal microbiota. Thus, consuming Okara we believe could impact the host microbial community and immunity. Therefore, in this research, we try to incorporate Okara as an additional ingredient for yogurt production through lactic acid fermentation. The objective of this study was to evaluate the feasibility of incorporating Okara into yogurt's formulation and determine its physicochemical properties and proximate parameters. The Okara was obtained from small manufacturing plant of soy milk and tofu production in Sri Kembangan, Selangor. The Okara collected was immediately dried until it reached 4% of moisture content. It was then grounded, vacuum packed, and stored at 4 degrees for future usage. In this experiment, 3 yogurt formulations were used and put to test. These 3 formulations are milk yogurt, Okara yogurt with skim milk, and Okara yogurt without skim milk. Okara yogurt used soy milk as the yogurt base medium. The commercial yogurt starter culture, which contained 5 types of lactic acid bacteria, was used as inoculum for the preparation of yogurt. All samples were subjected to physicochemical and microbiological analysis prior and after fermentation for comparison purposes. Now let's take a look at physicochemical properties of Okara yogurt before and after fermentation with lactic acid bacteria and compared to regular milk yogurt. From this table, we can see that all samples managed to reach pH 4.5 after 16 hours of fermentation, and the sugar content was reduced after fermentation. This indicates that fermentation took part in this process, and the use of Okara in yogurt formulation does not directly inhibit the fermentation process. And now, let's take a look at the viable cell count after fermentation. From this table, we can see that higher number of total viable cell count was observed in the Okara yogurt in comparison to regular milk yogurt. This is probably due to the presence of dietary fiber in the Okara that enhance the probiotic growth and viability. From this, we can say that the use of Okara in the yogurt formulation is very appropriate as it is a good growth medium for lactic acid bacteria. And lastly, let's take a look at the Proximal analysis of Okara yogurt with skim milk compared to regular milk yogurt that obtained from literature. In this table, we can see that the Okara yogurt contains higher protein and carbohydrates. Okara yogurt also contains a lower fat content but higher in energy and dietary fiber. In addition, a large amount of dietary fiber was also detected in Okara yogurt, as the Okara itself consists of insoluble fiber, but no fiber was detected in milk yogurt. So, as a conclusion, incorporating of Okara in yogurt preparation with combination of skim milk has resulted in better taste and higher number of total viable cell count when compared to regular milk yogurt. Through the microbial fermentation process, the protein and dietary fiber are converted into valuable bioactive metabolites such as peptides, amino acids, and insoluble dietary fiber, which could enhance the probiotic growth with extra health beneficial effects, which are potential for the development of functional ingredient for human consumption.